Whether it's washing your hands, taking a shower, or entering a grocery store, soap and hand sanitizer pumps are everywhere. But how do they work? The engineering world of pumps is a vast rabbit hole I did not expect to find myself in when looking at your average soap dispenser. Most soap dispenser pumps are a type of piston or plunger pump which stem from a larger family of reciprocating pumps which are classified as positive displacement pumps. While each one of these types of pumps could serve as their own video, I'm only going to be focusing on the piston or plunger pumps as these tend to be the most commonly used type in soap dispenser bottles and the ones I currently have access to. The soap pump is a positive displacement pump which is used to move liquid frequently with a set volume, with the help of valves and seals to move the liquid automatically through the system. The action of pumping is repeated and can be driven by screws, pistons, lobes, gears, vanes, and diaphragms. These pumps are mainly used where highly viscous or thicker liquids are required. With the pump basics established, let's start reversing. A majority of these piston or plunger pumps are comprised of the following components: a container to store the product, in our case soap, a dip tube to draw the product up, a pump housing unit which can contain a piston, a ball or a valve, and a spring, and then moving back outside, a gasket to help create the seal to prevent the product from getting out, and an actuator, or the top part of the pump where the product is dispensed. And finally, a closer or container seal, which is generally threaded for use with the gasket to make a watertight seal. No piston or plunger pump is created equal, and they can take many different shapes or sizes, but all follow a similar concept. The pump acts as an air suction device that draws the soap from the bottle to your hand, or in my case the table. When you press down on the actuator or the top of the pump, the piston moves and compresses the spring and upward air pressure draws the ball or valve upwards, along with the soap inside the container, into the dip tube and subsequently the pump housing. As you release the top of the pump or the actuator, the spring returns the piston and the actuator to its upright position. The ball or the valve is returned to its resting position, sealing the chamber and preventing the soap from flowing back down into the bottle. This initial pumping is called priming. When you press down on the actuator again, the soap is already in the chamber and will be drawn up through the stem and then out through the actuator into your hand. For larger pumps with a larger chamber, additional priming may be required before it'll start to dispense the soap. While all this only begins to scratch the surface of the vast pump world, maybe the next time you take a pump of hand sanitizer, you will consider the engineering complexities that make it possible. I hope you learned something, and thanks for watching.